Okay, this is just another rule. Basically, this is a continuation of what we did yesterday, all right? It's a little more tricky. It's not harder. It's just, you gotta pay attention, okay? Let me give you an example. All right, let's see.
It's not harder, it's always harder.
No, okay. So what we have here is, this is just an example. What's our base here? 2. Okay, exponentially, 2 to the 7th is 128. Okay, 2 to the 4th is 16. But let me show you what's going to happen. So watch. You'll help me count. 1, 2, 3, 4, 5, 6, 7. Over 1, 2, 3, 4. This example shows you what the rule is. Okay. Now, simple math, you may remember this, you may not, because I know fractions are your favorite. Watch what I'm getting ready to do. Those 2 cancel. These 2's cancel. Those 2's cancel. And those 2's cancel. So you are only left with 2 to the 3rd over 1. Again, how did I get 2 to the 3rd? Well, there's only 1, 2, 3 left. And everything else is gone, so there you go. Okay, well, you do the math. 2 to the 3rd, 2 times 2 is 4, 4 times 2 is 8. So actually, this answer would be equal to 8. All right, let's do another one. Whoops. That's a T. Okay, what's our base here? T. Okay, so again, watch me cancel. Addison. Can't do it. Did y'all hear what she said? You remember yesterday, the base has to be the same. You can't do anything. The base has to be the same. Good question. Shelby?
Didn't you just say, like, keep your base and do 7 times 4 or 4?
We're getting there. Yep, we're getting there. All right, so look. Those cancel, those cancel, those cancel. So all I'm left with is just 1 T, which is simply just T. Shelby has figured it out. The rule for division is, and I'm going to go back to the same, you simply subtract. Star this, all the above. I'm going to do green. Sorry, is that better? All right, this is what you need to know. Okay. It's not always going to be neat and pretty. It's going to be the same process as what you did for homework, what you did on these review problems, step by step. Okay. You can only do the same bases. The rules only apply to the same base. Will you have an answer that will be in fraction form? Absolutely. I'm going to go ahead and tell you, you will. Okay. Step by step. I'm not saying we're doing fractions. That's not what I'm saying, but we might have an answer that ends in a fraction. All right, y'all ready to do a few examples? All right, I'll just start with 2. 1, I'll do this one with you, and then I'll give you one to do on your own. Okay, like we've discussed, we can only, sorry. Let's do this one, and I'll do a new piece of paper. G squared, h to the fifth over gh squared. There you go. No, this is bad. All right, who wants to do this? I like calling on people. This is kind of fun. Who's got it?
I got this one.
Tyler? All right, let's go. What are we doing first?
Subtracting the G numbers.
Okay, so what do we have? G,
2 minus
right. What's 2 minus 1?
1.
1.
G, and then H5 minus H2 is H3.
Do we have anything on the bottom?
No.
No, everything canceled. Okay. You should have gotten this right here. Did everybody see that? Let me break it down and you can see G times G, H, there's your 5 H's, over G and 2 H's. Cancel, there's your 1 G on the top. Cancel, cancel, and you're left with. This is not a bad habit to get in because you may have some variables or numbers left on the bottom, okay? All right, I'm going to now give you a new piece of paper. Did everybody get this? Okay. That's level easy medium, okay? They are loud next door. Good gravy. K7. M to the 10th over K5 M to the 3rd. And I added a P on the top and the bottom. The rule says to subtract. Oh my gracious. Sorry.
Is that what people that wear glasses have to say?
Yeah. Okay, how many K's do we have? 2. Does that go on the numerator or denominator? So K squared. Guys, focus. M, how many M's do we have? What happens to the P's? Goodbye. 1 minus 1 is simply 0. Any number to the 0 power, do you know this?
0. 1. 1. You're dumb.
Okay. Let's do another. I'm just going to give this to you.
We're recording?
Yeah.
Yeah, Nick, if you go on all the videos.
Nick, pull your pants up. Oh my gosh, not in the middle of class.
Okay. Not appropriate. Not appropriate. All right, here we go. Here is a new rule, division. This actually should make a lot of sense. It's exactly what you learned yesterday. What happens to this exponent outside the parentheses? It goes to everything. It goes to everything. And if you haven't noticed, we're just going to do many examples. Look at example number 3. Everything in this problem is squared. Every variable, every number. All right, who's got this one with me? Alex. Let's do it together. Everything squared. What happens to the 3? What's 3 squared, Alex?
9.
9. All right, look at the p to the third squared. So how many p's do we have? Somebody saying it. 6. What's 3 times 2? 6. All right, so, and 7. Alex, what's 7? 7 squared is? 49. Can you simplify 9 over 49? No. All right, so look at number 4 by itself. 4x to the third over 5y to the fourth, all to the third power. Katie? P to the third power squared is p to the sixth. That's basically the rule from yesterday. So you have p to the third. That's that. All you have to do is tell me. Do you see? The rules from yesterday still apply. We're bringing it all in today. Okay, let's do more. You'll get it. So here, x to the third power is x to the, what's 3 times 3? 9. All right.
I knew that.
Look, this rule is this right here. Okay, that still is in play today. Okay, everything you learned yesterday comes in today. It's all still there, and we're going to keep adding. Okay, does that make sense now? Okay. We'll do more. You'll get it. All right, so what's 4 to the third? Everything in here is to the third power. 4 to the third, x to the ninth over 5 to the third, y to the 12th. 4 times 3 is 12. Okay. Now what's 4 to the third? 64. X to the ninth over 5 to the third is 125. Y to the 12th, and you are done.
Wait.
No, it's step by step. Step by step.
Doesn't it get harder?
You want me to make it harder?
That was the hard one. Yes, you did.
I'm gonna give you one more box and then I'll stop. It's that one. We get out of here at 10 after. Okay.
I thought you got here at 10.
Any number, that's the old schedule. Any number to the 0 power is 1. You have 1 over a, all to the 0 power. It is equal to 1. This is something you need to memorize, understand. Try it in a calculator. Any number to the 0 power will be 1. What? What's up?
How's it going?
Good. How are you?
Not bad.
All right. I have. Let's see. I think I'll wait. Hold on 1 second.
Review drops down.
All right, can I move this? We good? All right, last but not least, and then I have to make sure, can you go on LMS real quick for me and check something? Last thing, this is the negative exponent. I would stop talking because this may blow your mind.
Really?
Mhm. What's the assignment? Did I link it yet? I'm not sure I did. Is it there?
Homework?
It should look like this. Can you click on it?
Oh.
Is that that? Is it not a second page?
This is the page.
Okay. All right, so here is the last but not least box. The base, what do you notice about the exponent? It is negative. Look at what that negative exponent does. It makes it go to the bottom of the fraction. For example, x to the negative fourth is simply 1 over x to the fourth. 2 to the negative 3 is simply 1 over 2 to the third, which is 1 over 8. A negative 5b. What do you think about that? What goes to the denominator? Just the, so you have, the b stays put and you have a to the fifth here. We will touch more on this tomorrow, okay? What I need you to do, somebody remind me, okay? We gotta finish this. On your homework, you don't have this? I need everyone to go to LMS, since everyone is here. I need you to go to LMS. So there is a second page.